This is Dr. Carroll, and today's video is about abstract-based classes. So it may be desirable to declare a class as an abstract-based class. Well, then that begs the question, what is an abstract-based class? So an abstract-based class is a class that contains at least one pure virtual method. Well, that was great. Now, what's the definition of a pure virtual method? It is that it's a virtual method with an undefined body. That's interesting. Let's talk about when that would be useful. First, let's talk about syntax, though. So the syntax for this is we have virtual keyword before the declaration of the method, just as we've seen before. And an important part is that we set it to equals to 0. We set it equals to 0. And that changes it from just a virtual method to a pure virtual method. So that brings up some more rules that we have about inheritance and polymorphism. And that is that non-pure virtual methods must be implemented, as we talked about earlier. But pure virtual also the pure virtual methods must be overridden in the derived classes because they have no definition. We've set it equal to 0. Okay, and so we can't have an implementation of a pure virtual method because even if we did, it's going to be overridden in the derived class. So that makes it so that not having the definition of a method means that we can't have instantiations of abstract-based classes. Okay. And so they can only be used as the basis for other classes. And we'll talk in a minute about several examples of when that'd be very appropriate. So when should we use a pure virtual function? Well, when it's obvious that in our base class we need to provide some functionality, but we just don't have the information we need to how it's supposed to be implemented. And we can only get that in the derived classes. So when we identify several classes that have commonality, we then take that commonality out of those classes, pull it into a base class, and then depending on the nature of it, that base class may be an abstract base class or may not be. It's abstract if we can't fully implement it, but we have that common functionality there. So let's look at some examples. Let's say we have a person class and your program doesn't have a definition for a generic person, but we need to print out information about that person. So we make it virtual so that it can be overridden in the base classes, and we want to make it purely virtual, a pure virtual method, so that we can't have an instantiation of a person class. And furthermore, that each of the derived classes are required then to provide their own definition for a print info class. Another example, if we had a shape or say a polygon class and we had a drawing program, the program doesn't know how to draw a shape, just a generic shape. It knows how to draw squares, circles, rectangles, hexagons, etc., but it doesn't know how to draw just a shape. But we could find it very useful to have a draw method because that's going to be common among all the different shapes. So we make it virtual so that we can have polymorphism, but we make it equal to 0, making a pure virtual method requiring each of the derived classes to implement it. And that's it for today's video.